Dude, get your crap together. I watched your video about how RTX 4090 is limited by 7800X3D and there is no CPU on the market right now which would solve it like an hour ago. And then this video how the same GPU is the limitation. Either you have no clue what you are talking about or you are not the best communicator of the thoughts you have. My last video talking about CPU bottlenecks seems to have stirred up a lot of either misunderstanding what I was saying or people who are just genuinely confused about bottlenecks. So I'm not going to rule out that perhaps I maybe didn't communicate fully what I was saying, or maybe people didn't watch the whole video or listen to everything that I said, but you know what? We're going to go ahead and try to clear up this as well as a bunch of other questions, because I also had a lot of people who are genuinely curious about, wait, can you explain something to someone who might not know, like myself? If the GPU is at 50 to 80% utilization and is waiting on the CPU, why does the CPU utilization sit at about 50%? Why is it not at 80, 90% if the component doing all the legwork and trying to pump out frames while the GPU is chilling out at the spa? Or in other words, how can you be CPU limited if the full CPU is not being utilized at 100% or near 100%? And I see other similar comments saying, I don't even understand what to look at when videos talk about bottlenecks. It sounds so obvious, but I'm like, is it a bottleneck when the GPU is at 99% and the CPU not? Or the other way around? How do I make my system use more of the CPU? Do I need a higher end CPU? I'm mostly confused and don't understand the subject, sorry. And there's a lot of comments like these. I'm just highlighting a few of them to get the overall picture. If the CPU never goes above around 70% max in those games, how is it a CPU bottleneck? And I do have a really helpful comment here trying to explain how to interpret usage percentages for the CPU and the GPU to interpret how you can tell which thing is the bottleneck. And I think this is a very good comment, and we could certainly take a look at that. And the other big comment and reaction to the video was, you're using a horrible performing game, although you used several games there, not just one, but you're not CPU limited, you're bad code limited. And there was a lot of comments like that. Here's another one. This is such a terrible take. It's not a CPU problem, it's a trash engine problem. Absolutely. The hardware is more than capable, complaining that shoddy code runs poorly and blaming the hardware. LOL. Okay, so a lot of stuff going on here. Again, we need to clear up a lot of understanding about CPU and GPU bottlenecking, what I mean by that, and how to identify it, as well as what about this take on whether it's a CPU problem versus a trash engine problem. And then generally just what do I mean about like the 4090 is limited by a 7800X3D, but in another video I'm saying the 7800X3D is limited by the 4090. So there's a lot to unpack here. So first of all, how about we respond to this one? So what do I mean? Like, am I being inconsistent when in one video I say the 4090 is limited by the 7800X3D, but in the very next video I'm calling out benchmarks where the 4090 is clearly the limiting factor, not the 7800X3D. How can it be possible that the 4090 is limited by the 7800X3D and not limited by the 7800X3D? And the distinction here is it depends on the game you're playing, what scene you're doing in that game, and what settings you're using in the game. And including monitor resolution, graphic settings, especially ray tracing. That's a really big one for CPU performance, all of that. So in other words, I think that this is actually representative of a larger misunderstanding about CPU and GPU bottlenecks. A lot of people seem to be under the impression that a certain CPU will either always be a bottleneck to a certain GPU or the other way around. A certain GPU will always be a bottleneck to a certain CPU. And some people at least have some idea that maybe monitor resolution has something to do with it. So it can depend, but in general, it's just more complicated than that. Even at the same monitor resolution, and even within the same game and using the same graphic settings, you can be switching between being CPU limited and GPU limited depending on what is going on. So it is not in any way inconsistent to say that a 7800X3D can bottleneck a 4090, but also say that a 4090 can bottleneck a 7800X3D. So maybe I need to draw things out. Sorry if I just blinded you. So what do we mean by bottlenecking? A bottleneck, so if you have a glass bottle that you're drinking out of, it's about the same way throughout the base of it, and then it tapers off at the mouth, restricting the flow. So even if you try to pour the water out or whatever's in the bottle out as fast as you can, it is limited by the opening of the bottle neck. That's what this phrase is talking about. It is something creating a limit to how fast something can flow. So here I'm going to try to draw this out visually. So you have frames per second, and right now I'm going to say that this is like a river of frames per second, even though that's not how frames per second actually work. I'm trying to show this in terms of the bottleneck analogy. So if a game was able to run about the same speed on the CPU and the GPU at a given time, it would look something like this. There's no real difference between how fast the CPU and the GPU could go. They would both be going as fast as they can go. Now, here's the thing. Depending on what's happening in the game, the demand can suddenly become a lot higher on the CPU or a lot higher on the GPU. For the CPU, maybe suddenly you have a whole bunch of NPCs with all of their AI about how they're moving, and that's calculated on the CPU. And suddenly the CPU isn't running that scene as fast as it could before. So what would happen in that scene is that the CPU performance can no longer have the FPS flowing, but nothing that the GPU is calculating got any more difficult. So what you can see here is that as we've transitioned into this scene that becomes more CPU demanding, or using graphic settings that become more CPU demanding, we start to get a bottleneck. Do you guys see what we're talking about here? This is a glass bottle turned on its side. This is your bottleneck. There's the lid on your bottle, right? So the frames per second can only go as fast as the thing that is at that point in time limiting it. In other words, the GPU is now waiting on the CPU to finish what it's doing before the next frame can be presented. This is what we mean by a bottleneck, and the CPU can become the bottleneck depending on what you ask it to do, even if this entire thing is still playing the same game. But we could then very easily run out of town. Maybe this was when we came into a big city, and now we run out of a town, and now the workload on the CPU suddenly lightens. There's almost nothing happening. The CPU is not at all limiting the FPS. But let's say the things that the GPU is doing are still exactly as demanding as they were all along. So if the things the GPU are doing is exactly as demanding as they were all along, what you have now is a situation where the CPU could go faster, but the GPU can't, right? Or what could actually happen is maybe now suddenly you get into a combat situation and there's all these flashy effects happening and all sorts of things, and now the GPU is taking longer to produce each frame. And again, what you're getting now is a GPU bottleneck. The overall frame rate can only go as fast as the width of that. Or in other words, the frame times cannot get any faster than how long it takes the GPU to compute them. So within the same game, at the same graphic settings, depending on what is happening in the scene, either the CPU or the GPU can become the limiting factor to how fast the game can go. Or you can artificially create limiting factors like locking your frame rates to a certain FPS cap or all sorts of things. Now, the other thing that can cause these differences is changes to the graphic settings that you're using. So if we go back to this analogy right here, again, maybe with the CPU, maybe it's not that you're running into a town. Maybe what was happening right here that caused this bottleneck is you enabled ray tracing. And this was definitely something that was causing the limited CPU performance in the games that I was showing in this video. All three of them were using ray tracing. And ray tracing, a lot of people think of that as being a GPU thing because ray tracing is generally marketed as a GPU feature. You're looking like NVIDIA is better than AMD at ray tracing, or the RTX GPUs are using the ray tracing. So it's a GPU thing. And a massive amount of ray tracing is indeed calculated on the GPU. So turning on ray tracing, depending on how heavy duty the ray tracing effects are and all sorts of things, absolutely does change our GPU performance. It does indeed limit the performance of the GPU. But there's situations where it's actually going to limit the CPU performance even more than it limits the GPU performance, because the 4090 has a lot of ray tracing performance. But the CPU is still having to do things like the BVH structure. So this restricting of frame rate right here could have been turning on RT, right? So if we turn on RT, now both the CPU and the GPU are working harder, but maybe it took a heavier burden onto the CPU. Now, maybe I should actually just literally show this in Jedi Survivor. So right now I have Jedi Survivor loaded up again. This time I'm showing the individual CPU cores in case we want to talk about it. But right now ray tracing is enabled, and you can see that the GPU is sitting at 70 to 80% utilization. I could run through town. Things change a little bit. The GPU is now down to like 50 to 60% utilization. I can stand still. So the GPU is clearly waiting for something, right? But we could turn off ray tracing. So if we turn off ray tracing, let's see what happens to overall performance. Well, performance numbers overall go way up. We're now up to around 143 FPS, so we've actually relieved the burden on both things, although it does clearly look like we are still somewhat the GPU waiting on the CPU in these scenes, which is interesting. However, again, I was also playing with the rendering resolution, because right now we have DLSS happening. So DLSS performance mode, we could turn DLSS off. And if I turn DLSS off and I have ray tracing off, you'll see that the GPU usage is now 99%, meaning that the GPU is fully utilized. You can also see, based on its wattage, 430 watts, that the GPU really is doing all it can do, right? It's being fully used. So maybe if we go back to our whiteboard example, the other thing we can think of is what happens when you change rendering resolution. So when we change rendering resolution, the GPU burden goes way down. If there's less pixels to calculate, then our GPU now can go way wider. So this could be use DLSS, right? Something like that, or just turn down the rendering resolution. But if we turn off DLSS again, we could further restrict the GPU performance. But notice that the rendering resolution of the game doesn't really have a major effect on what the CPU is doing. So it can kind of still be doing this, if that makes sense. Like the rendering resolution of the game can have some effect on the CPU, but it's generally not a large burden. It might put a little bit a heavier workload, but it's not going to be a massive change. But it massively reduces the burden on the GPU workload. So there's a lot of things going on here. If you're using ray tracing, if you're not using ray tracing, depending on the internal rendering resolution. So as we can see right here, I am now at a situation where the 4090 is bottlenecking the 7800X3D. The 7800X3D could go faster right now, but it is feeding frames to the 4090 as fast as it can, and the 4090 is now currently only able to calculate these frames at about 73 frames per second. So if we get back to responding to this comment. So, dude, get your crap together. I watched your video about how RTX 4090 is limited by 7800X3D, and there is no CPU on the market right now which would solve it, like an hour ago. And then this video shows how the same GPU is the limitation. Either you have no clue what you're talking about, or you are not the best communicator of the thoughts you have. So I am now attempting a better communication of the thoughts that I have. The 7800X3D can limit the 4090, and the 4090 can limit the 7800X3D depending on what settings you're using, even within the same game, or indeed which area of the game you are in. Because another thing that I think is fair to mention is that this section of the game, I'm in Kobo in this town area. This town area tends to put a lot more burden on the CPU, like I was saying, than if you're out of town. So if I went ahead and maybe we get back to a CPU bottleneck in town by going to, maybe DLSS balanced. So again, by going to DLSS balanced, we are reducing the GPU limit so the GPU can flow more frames, right? So and so now you can see that the GPU utilization is not at 99% anymore. We're bouncing around 93% or so GPU utilization. Again, where are we looking for this? We're looking at GPU utilization around here, right? So it was locked at 99% without DLSS on, and now as I'm moving around, we're below 99%. So the other thing is, okay, so what if I just leave the town area? So as we leave the town area, it's likely to have a different load on the CPU than when we are in the town area. Now, I haven't tested this particular scene yet. I do know there are areas in this game where it can be much less CPU bottlenecked. Also standing still versus running, because we're having to stream in all these new areas of the game and things like that. So anyway, I'm filming this video live without editing, but see, if I stand still now, it's closer to that 98, 99% GPU utilization, because there is currently less for the CPU to be doing when I'm standing here out in the bush, right? if that makes sense, right? So even within the same game, where you are standing, what is happening on the screen. Now, if I look this direction with more stuff happening that way, it seemed like suddenly the CPU burden went up. The other thing I think that we need to clear up here is these questions. So could you explain something to someone who might not know, like myself? If the GPU is at 50 to 80% utilization and is waiting on the CPU, why does the CPU utilization sit at 50%? Why not 80 to 90%? We had a lot of comments like that. What do I even look at when I'm talking about usage percentages to identify a bottleneck, and is there anything I can do? And then, again, if the CPU never goes above 70% max in these games, how is it a CPU bottleneck? I really like the explanation in this comment, so I'll go ahead and highlight it. So he says CPU usage confuses people. Many people think if a CPU has 50% usage that you can't be CPU bottlenecked because they simply don't understand enough about computers. You always go by GPU usage, because generally speaking, the code can be extremely parallel and thus close to 100% usage. To oversimplify, this means a GPU is fully saturated, and if it shows 50% at maximum GPU frequency, then you're using about half of its potential, so are thus bottlenecked by the CPU, assuming no software FPS cap causes this. So, if you had a game that had no branching code, and thus you could only run on one core at a time, you could only use one core worth out of your 100% of your CPU. So if it was a 4-core, 4-thread CPU, then in this scenario, you could only use 25% of the CPU, yet could still be bottlenecking the graphics card. And here's the TLDR. If your GPU usage is near 100%, you are GPU bottlenecked. If your GPU usage is below 100%, this generally indicates a CPU bottleneck. CPU usage near 100% probably does indicate a CPU bottleneck, but CPU usage below 100% can't tell you where the bottleneck is. And that's the key, is it's just inconclusive. If your CPU usage isn't at 100%, that doesn't mean you aren't CPU bottlenecked, because, like he's mentioning here, games will generally not be using all of the cores and threads that you have available at any given time. And again, what we mean by bottleneck is how fast can the frames per second flow, right? If the GPU could flow frames at a higher speed than the CPU, but the CPU is flowing frames along at a lesser rate, it is creating a bottleneck in that stream of frames per second, right? So, in other words, you can be CPU limited, meaning bottlenecked, meaning your GPU could go faster, but it's waiting for the CPU, even if the CPU is not 100% using every core, because the cores that it's using could be maxing out. So that's an important distinction. Now, another big thing I saw in the comment section is then people wanting to blame the game code. And I don't think that's necessarily wrong. But let's talk a little bit about that. Now, these comments I actually screenshot aren't the ones saying it, but there were other comments talking about this where it's like they understood that 50% CPU utilization means it's only using 50% of the cores, but then said that that meant, therefore, the game is badly optimized to take advantage of the CPU. Now, I want to make an important distinction right now so I'm not miscommunicating or being misinterpreted. I am absolutely not saying that Jedi Survivor is an example of a well-optimized game or couldn't be better optimized for the CPU. And in that original video, I specifically stated it's notoriously a badly optimized game. But what I am saying, though, is that even in well-optimized games, it is often the case that it can't use an indefinite number of CPU cores and threads. It's because the work that a CPU does is very different than the work that a GPU does. So a GPU, the kinds of work that it does are very easy to run in parallel, meaning you can give each GPU core a different thing to do. They can compute them all separately, output them all at the same time, and now the frame is ready to go. For example, to really oversimplify this, if your GPU's job is to decide what color every pixel is on your screen, and you have 1 million pixels on your screen and 1 million GPU cores, you could assign each GPU core the job of determining one of those pixels, and if they all do that job and then present them at the same time, then that was perfect efficiency, and they were all ready at the same time. So if you had one core trying to compute all 1 million pixels, it would take 1 million times as long as each individual pixel being computed in parallel and then presenting at the same time. That's the kind of thing that a GPU does. It massively parallel processes. However, that's not the case for the type of work that a CPU is doing. In games, a lot of times there's a main game logic thread that can only be split apart so much and have any gains. Now, sometimes other things that are going on could be separated off to different threads, so you can get some multi-threading going on, but there can be diminishing returns to jobs that have to be, by splitting them off and then pulling them back together, lose some efficiency or are just difficult to pull apart in general. I think a classic example that I'm probably misquoting here when explaining this in like computer science classes about like parallelization, let's say, remember how I said that, okay, if you have 1 million pixels and you just need to decide what color each of them is, you can split that up into 1 million different cores and it's 1 million times faster. What if your job is growing a baby? Right? So you have a pregnant woman and it might take her 9 months to produce the new baby. Would it be faster to chop the baby up into 9 pieces, put each of them into a different woman, let the baby cook for a month, take all the parts out, put them back into the original woman, and then is she now ready to give birth to a healthy baby? Okay, do you see what I'm saying? There are some tasks that chopping it up into pieces, separating it out, and then pulling them all back together didn't make it faster. Okay, so with that being said, a game not being able to fully utilize all of the CPU cores is not an indication that you aren't CPU bottlenecked, and it's also not in and of itself an indication of a poorly coded game, because certain tasks just have limits to how beneficial parallelization can be. Now, that being said, I absolutely want to respond to people saying that I was implying that I'm blaming the CPU and should be blaming the game and therefore had a horrible take. So my point in that video was never trying to excuse those games for their optimization or say that they shouldn't have run better on the hardware. That was never a claim I made in that video. Now, that does seem to be what some people took away from that video. So maybe I should have communicated better, right? Maybe I was a bad communicator of my thoughts. So I will try to clarify them a bit more here. So, what are my thoughts on a game being CPU limited versus bad code limited, right? Or this is such a terrible take. It's not a CPU problem, it's a trash engine problem. The hardware is more than capable, complaining that shoddy code runs poorly and blaming the hardware. So what I want to be clear here is there's a difference between blame and saying whether you're bottlenecked, okay? So if I go back to this picture, at no point in this picture am I blaming the CPU or the GPU for being bad. I'm just stating that either the CPU is waiting for the GPU to finish or the GPU is waiting on the CPU to finish. Therefore, one of them is limiting the flow of frames per second, which I am calling a bottleneck because that's my understanding of the term bottleneck. You are restricting the flow, and things are having to wait for that, right? So that's my point. So I was identifying whether the 4090 was waiting for the 7800X3D, and I was giving examples of cases where that was true. Because the whole point of this video over here, what misinformation about CPU bottlenecks was I sick about? What I stated I was replying to is there were many comments talking about the performance of new CPUs, or maybe the lack of better performance on new CPUs, making the claim that you would never notice a faster CPU anyway in realistic gaming situations, especially at higher resolutions like 1440p or 4K. So what I was doing in this video is specifically showing cases where at settings you might realistically want to use, the CPU was indeed the limiting factor. Now, why did I choose badly optimized games to show that off? Because that's a real thing. These are games I literally played these games myself on this system and identified that I was CPU bottlenecked at those settings and was frustrated by that. Now, am I blaming the 7800X3D for not being faster? No. I'm identifying that the 4090 is waiting for it, which is not the same thing as blaming the 7800X3D for not being fast enough. What I am saying, what I would actually absolutely agree with, which is what a lot of the top comments on this video are about, is that these games can often be very poorly optimized. They are not running as well as this hardware probably could do. So in other words, I guess what I'm saying, my frustration with these type of comments is I think that these comments are creating a false sense of mutual exclusivity. So the idea of having a badly optimized game and being CPU limited or CPU bottlenecked are not mutually exclusive. In fact, once you identify that you are either CPU or GPU bottlenecked, what can you do as the user? Because that's kind of what I got another comment. So like, how do I make my system use more of the CPU? So again, these aren't mutually exclusive. So once you've identified your CPU limited, you might be like, okay, so what is the root cause and can I do anything about it? So again, we are CPU bottlenecked, but why? Maybe the game is coded poorly for how it's utilizing the CPU, causing it to be restricting the flow of the FPS. So identifying that the flow of FPS is restricted by the CPU is in no way saying that the root cause of that wasn't poor optimization or excusing the optimization. And I think in games like Jedi Survivor, and even in this video, I specifically stated this is a poorly optimized game, okay? So poor code, bad optimization can absolutely be the cause of this GPU having to wait for the CPU, because the CPU code could probably have been done more efficiently, if that makes sense, okay? So what I'm saying is, I agree that we are bad code limited, and the bad code is causing the GPU to wait for the CPU, which is a CPU bottleneck. I'm not blaming the hardware, I'm identifying it. And then we get back to the, okay, so what can I do about it? How do I make my system use more of the CPU? Well, one of the things I just showed you in today's video was turn off ray tracing. In the specific games I was showing in that video, I had ray tracing on because that was contributing to the CPU bottleneck. And so by turning off ray tracing, if you had it on in the first place, that would be a thing you could do to relieve CPU burden. But a lot of times, game settings don't give you a lot of scalability for the CPU. Sometimes there's crowd density settings that you can turn down, and that tends to be a CPU driven thing. Sometimes view distance could change it because like it's changing how many like draw calls are all for the if you can view more stuff. But a lot of times there's not a lot the end user can do. So how do you make the system use more CPU? I don't know, talk to the game developers, make them code it better, or, right? So that's what I'm saying. I'm not arguing that that a huge part of the underlying issue isn't the game code. But what I was stating in this video is that it's frustrating that sometimes as the end user of a game, if the game was coded poorly, but you still want to play it, you are left with few choices. One choice could be to try to power through a poorly coded game using ridiculously powerful hardware. And what I was pointing out in this video is it's unfortunate that it looks like more powerful CPU hardware isn't coming this generation for gaming. At least that was the case during this video. In my latest video, I've also talked about, we got some leaked benchmarks for the 9800X3D, we could look at that. But that was my point. It was that if you need to power through poor CPU performance, it's kind of disappointing if we don't get more CPU performance. Now, should game developers make better use of the performance that they have? Absolutely. They absolutely should. And so that is anyway, topic for another video. So are games often running poorly on the CPU, especially in Unreal Engine, and especially when using ray tracing, especially ray tracing in Unreal Engine 4? Absolutely. But that doesn't change the fact that it is causing a CPU bottleneck where my GPU is having to wait for the CPU. And it would be cool if better CPUs came out where they could, what if I install new CPU, right? Install new CPU. I don't really want to write it out, but you get the idea. And that now opens up the flow a little bit more because as the end user, again, there's that, how do I make my system use more CPU? Well, sometimes you can't. And if the game devs don't make their game run better, I'm not saying that everybody should run out and buy better CPUs. And there was a lot of comments saying boycott the games that don't run well. And you could absolutely make that choice because lots of games do run better. Buy those. But anyway, the last thought I'll leave you with is I think that some of this problem comes from game developers targeting 30 FPS on the PlayStation 5. Because a 7800X3D often has about twice the gaming performance of the CPU in the PS5. It varies game to game. That's a really rough figure. But if a game is developed around achieving a 30 FPS limit on the PS5, then even high-end hardware like a 7800X3D might be limited to around 60 FPS at those settings. And a game like Jedi Survivor, I think its ray tracing mode was targeting 30 FPS on consoles, and therefore that kind of explains, doesn't excuse, but explains what was going on with that kind of a situation. All right, this video got way longer than I originally intended, but I had a lot of stuff to respond to in it. So anyway, hopefully we are more clear what I mean by CPU and GPU bottlenecked, that it can be different even within the same game depending on the scene and the graphic settings, and various games have very different usages of CPU and GPU. It is not mutually exclusive or at all times. The games will often not use all the cores, therefore showing 50% CPU utilization doesn't mean you aren't being limited in performance by the CPU. Anyway, all sorts of stuff we covered in this video, and yes, I absolutely agree that tons of games are coded poorly or using an engine that's running poorly on the CPU. Absolutely agree with all of that, but that it's not mutually exclusive to being CPU limited. Anyway, have an excellent day, everybody.